Hey class, Mr. Modin here with a video on finding vertical asymptotes. So some of the homework problems don't actually tell you to take a limit, and you kind of have to figure it out on your own, and I thought I'd give you some help with that. So this first question says, find any vertical asymptotes, justify with limits. And here's our function. It's a rational function. And hopefully you notice that vertical asymptotes, if you recall from the definition, occur when the limit approaching a finite number, so briefly the definition was a limit approaching a finite number from either direction, so you might write that as plus or minus perhaps, of a function yields plus or minus infinity. So if that happens, then you have a vertical asymptote, right? But the real question is, what numbers might you approach? What you got to find are candidates that may produce infinity when you take the limit at those numbers. And in short, those candidates occur when the denominator is equal to 0. It's a little more nuanced than that, as we'll see, but that gives you an idea of where to look. So let's take a look at this function. Right away, a couple numbers should come to mind. It looks like if I plug in 5 or negative 5 in for x here, I should have a 0 in the denominator, which, as we know, is bad news. So I'm going to take the limit as x approaches 5. Right, and I got that again from setting the bottom equal to 0. I didn't actually solve it, but hopefully you can see that you set it equal to 0. You can find 5 and negative 5 of 2x over x squared minus 25. And I want to see, does that produce infinity? Right? Well, I can't factor this, and I can't rationalize it with a conjugate. So instead what I'm going to do is I'm going to take a one-sided limit. So rather than 5, let's do 5 plus, just to make our lives a little bit easier. 5 plus. So I'm going to plug in 5 plus into here and here and see what happens. Well, on top I get 10 plus, positive number. And bottom I get 5 plus squared minus 25. And a little bit more than 5 times itself will give me a little bit more than 25, right? So 25 plus minus 25. Well, 25 and some crumbs is basically 25.001, right? Take away 25 will just leave me a little bit of positive crumbage to make up a word. So that gives me 10, a bit more than 10 divided by a bit more than 0. So let's worry about the signs first. Positive divided by positive will give me a positive result. 10, a number, a finite number divided by a very, very small finite number will give me a positive infinity. So right away, 5 plus produced a positive infinity. So one of our vertical asymptotes is definitely x approaches 5. That comes from this 5 right here, which further came from this setting the bottom equal to 0. The other possible candidate is x approaching negative 5, right? So the limit as x approaches negative 5. Let's do this from the left. You sort of have a choice of which one you want to do. You don't have to do both. If you recall, the definition is very open. Right? So if any of the following are true, if you approach either direction and it produces either infinity, bingo, you got a vertical asymptote. Right? Let me straighten this a bit. So x approaches negative 5 from the left of the same function. Plug it in. It gives me negative 10 from the left on top. Negative 5 from the left squared minus 25. Now this is sort of like negative 5.0001, right? So you got to think carefully about what happens here. Negative 10 from the left. A bit more or a bit less than negative 5 would be negative 5.0001 times itself. Well, the signage here, negative times itself will become positive, and then 5 positive, essentially the absolute value squared will give me 25 positive, right? Take away 25 will give me 0 positive like before. Negative 10 on top. Negative on top, positive on bottom gives me a negative result. And based on the tiny number divided going into a big number, that goes in infinitely many times. So we get negative infinity there. So x equals negative 5 is also a vertical asymptote. Why? Because approaching a finite value produced an infinite result. So it looks as though all you got to do is set the bottom equal to 0 and take the limits there from either side, and you're in business. It's not quite as simple. Let's take a look at the second example here. G of t is 4t minus 8 over t squared minus 4. Now, right away you might think, well, very similar to this previous problem, I'm just going to set the limits at positive 2 and negative 2, and it's at the bottom equal to 0. But keep in mind, the previous problem, we could not factor this thing, right? We couldn't rewrite it in any way. That is not the case here. So we can take the original function and turn it into its simplest form. I'm going to factor out a 4 on top, and that will give me t minus 2, right? And on bottom, I get t plus 2, t minus 2. Well, what do you know? I can cancel. Giving me, really, the function is equivalent to 4 over t plus 2. So now the only candidate for a vertical asymptote would be setting the bottom equal to 0. T plus 2 equals 0 implies that t is equal to negative 2. That's my candidate for a vertical asymptote. So all I need to do to justify it is to take the limit as t, in this case, approaches negative 2 from either direction. I'm going to choose the left direction of my new and improved function, which is this one right here, and see if I get infinity. If I do, then the candidate has been confirmed. So plug it in, and we get 4 over negative 2 from the left, plus 2. If you're not sure what that is, that's negative 2.0001, right? Plus 2 would give me a little bit below 0, right? Negative 2 on the number line might be here, 0 might be there, 2 negative is right here, and then jump forward 2 spots, you're still below. So that's there, 4 on top. Positive divided by a negative is a negative result. A number divided by an infinitesimal is negative infinity. So indeed, t equals negative 2 is a vertical asymptote. And this is our justification. Alrighty, hope this helps.